Today we're going to be tuning PIDs in Phoenix Tuner. I've showed you guys how to do it in Sim. Now we're going to do it in real life. So the first thing we're going to do is we're going to enable the robot, because in order to enable other stuff we need to enable the robot. So that's what we're going to do here. And then we're going to click on this tab right here. Actually, before I do that, I'm going to set all of these to 0.
You are not allowed in this room. You are not allowed in this room.
And then whenever you want to flash configs or you want to change the configs in Phoenix Tuner, we're going to do it up here. It's going to make that little noise. That means that it's pushed. So now that we have the robot enabled, we're going to enable I'm tuning the elevator now. So we're going to enable the elevator motor, and we are going to put it in voltage out. So right now, the elevator is not moving. And the reason I know that is because I'm here in person, but also because I can plot position. So I can plot position and I can plot velocity. These things are helpful whenever you're tuning because we're doing motion magic. So now we can play it and we can see that if I set it to like 1, you can see it's going up. So if you guys remember, whenever we're tuning PIDs, we want to find the value that's as close to 0 as possible, but it's not 0. Sorry, the highest voltage that you can apply that doesn't make the motor move. So if we do 0.5, then it's trying to move, but it can't. So that's good. If we do 0.6, you can see it's moving slightly. And that's not good. Actually, we can see here whenever we did 0.5, it moved a little bit. So even 0.5 is a little bit too big. If we do 0.4, it still moved up slightly. Let's just try like 0.1. 0.1 doesn't do anything. So then we can double it and go to 0.2. 0.2 still isn't doing anything. If we do 0.4 though, we saw 0.4 did something. So 0.3. 0.3 it moved up a little bit. So whenever you press enter, you disable, so you're gonna have to re-enable if you do that. So 0.2 was fine. It did a little bit of a jump there, but it seems like 0.2 is about good. So this is going to be our kg value. So if you watch the other video, then you'd know that right now we're tuning kg. So kg we're going to put as 0.2, and then we're going to flash that to the radio, to the motor. This gravity type is important. We're using an elevator, so gravity is going to be static.
Can I borrow your?
Yeah.
Are you using your Wi-Fi adapter thing with you?
Yeah. So now that we've done that, we're gonna sorry about that. Now that we did that, we are going to tune our PID values. So we're gonna not use any motion magic now. So motion magic constants can be found at the very bottom. So I'm gonna set all these to 0 just for now. And then I'm gonna go to position voltage. And this is gonna be the way that we tune our stuff. So I'm gonna set this back to 1. Every time it makes a little sound, that means that your constants have been pushed. So you heard it move a little bit, or you can see it on here too. So if we go to 5, that beeping sound means that your KP is there, but it's a little bit too low. So I'm gonna try increasing it a little bit. And that's pretty good. So then if we go to like 10, it's still beeping a little bit, so that means that it's kind of struggling to get there. If I go back down to 5, and go back to 10, and we go to 15, then you can see this graph is honestly pretty good. But if I'm gonna overlay a video of this on whenever I actually upload it, you can see that it's very scary. And if I set this to 0, it's like slamming down, and we don't really want that. So what we're gonna do is yeah, so if I'm gonna record this just because it's kind of crazy. Oh, I just disconnected. So that's something that can happen. So if I go to 0, if I go to 30, I come back down to 0, it is basically slamming on the thing, and that can be really dangerous if we have if we set our position to be too low, because if we slam it too hard, then it's gonna cause issues, and we don't want that to happen. So in order to avoid it breaking, if we want it to not break. No, it's fine. It wasn't plugged in good anyways.
Oh, it wasn't?
Sorry about that. The wire's disconnected. So, in order to avoid it from like catastrophically failing or like causing any breakages, then we need to tune our motion magic. So, what I do is, in order to tune the cruise velocity, I set it to however I want it, how fast I want it to go. So like 0.9 is probably what I'd want it to go like speed wise. Sorry, we aren't gonna use that. We're gonna use duty cycle, because duty cycle is how fast we want it to go, and then we're gonna enable it, but then we're gonna really quickly disable it because it's gonna be going at basically full speed. Okay, so now that you've done that, you can pause, and then what we're gonna do is we are going to use our left mouse in order to see the maximum velocity it went to. So it went to about 63. So that's gonna be our max velocity, and then we're gonna push that to the robot, and then we are going to go to our motion magic voltage, and then we are going to set our position, and then we're gonna go. Actually, we're gonna set our acceleration and our jerk too. So, hello guys, this is me from the future. Past me spent a lot of time trying to figure this out, but in order to figure out what your acceleration and what your jerk should be, you should be thinking about how fast you want your mechanism to go. So in the video, I have 60 set to my my cruise velocity, and so in order to figure out my acceleration and my jerk, what I should have done is considered how fast do I want my robot to accelerate to that velocity. So in the video, I end up going 300 for my acceleration. And so if we do 360 divided by 300, that's 1/5 of a second in order to accelerate up to that cruise velocity. And honestly, I could have gone even higher, but that's the one I chose because I wasn't thinking well whenever I recorded that video. Same thing for the jerk. You want to consider how fast you want the jerk to be in order to to accelerate to that value you want. So, for example, in the video, I think I did twice the acceleration, so that means half a second. So you do acceleration divided by jerk to get your time to accelerate to that value. So I chose 1200 for my jerk, or yeah, I think I chose 1000 for my jerk and 300 for my acceleration. So that's about 3/10 of a second to get up to the acceleration you want. If I was going to do it again, I would probably have my acceleration to be 600, so that it's 1/10 of a second, and then my jerk would be something like 6000 or I wouldn't even have a jerk because jerk is optional. Most of the time you can get away with velocity and acceleration. So I'm gonna cut out a lot of the parts, a lot of the tuning that I did for motion magic, because a lot of it was wrong, and I don't want you guys to use wrong information. So just to recap, find your velocity like how I did in the video, and then use math to figure out how fast, or use your constraints to figure out how fast you want your motion to accelerate, and then if needed add jerk, but keep it at 0 so that way it doesn't interfere with your velocity or your acceleration. So now, why is it not working?
Oh, those my new cooks.
So now I'm going to, what is the issue?
You say enable the robot.
Is the robot? Oh, see, this is why I need other people around. You make sure you have it enabled, because I obviously didn't have it enabled. And you can see here, in order to like see how fast it's going, you can graph duty cycle, and if we look at duty cycle, make sure you pause whenever you do this. If we look at our duty cycle, it's going pretty slow. Like at its max, it's going at like 0.16. So that's probably an acceleration issue. So I'm gonna, because we know our cruise velocity is like, that's pretty accurate. 60 is pretty good. So I'm gonna keep increasing my acceleration until we get to that. I'm gonna re-enable. And then I'm also gonna go up to, okay, so if I zoom in and I go back down to like 5, you can see how it's like, it's got this like smooth curve. That means that our acceleration is too low. So it's too smooth. So I'm gonna increase this to like 300, and then now. Okay, so now you can see that this so it gets up to speed, but then the speed it's at whenever it's at 60, that max speed is actually too slow. So what I'm gonna do is I'm gonna increase it to 100. And it's slightly faster now. But I think I'm gonna keep increasing it until we get the speed that we want. Yeah, for some reason it's the same speed. I don't know why. What if I increase this to like...
Acceleration.
For some reason it's not...
Maybe the acceleration.
Maybe. Let's try increasing the acceleration.
Oh, that's slow. Maybe decrease the acceleration.
You know, I create...
Maybe you should.
Oh, I should do... So what I just found out is that your jerk value should always be higher than your motion magic acceleration. So before I had 60, 120, and then 240, but that means that in order to reach your acceleration value, it would take twice as long to reach your max acceleration, which would then impact how fast it can go. So whenever you increase your acceleration, always make sure that your jerk is faster than that, because otherwise it's gonna be like the acceleration won't be able to catch up essentially. So now if we look at our position, you can see the duty cycle peaks pretty close to max speed. I bet if we decrease this a little bit and we play, and then always reset zoom, because sometimes it can be kind of weird. So now if we check this, you can see that our duty cycle reaches 1 at its peak. So that's good. We want our duty cycle to be at 1 for as long as possible, but we don't want it to always be at 1, because otherwise it could cause some damage to the motor. So now if we go to like 5 or 0, you can see it accelerates a lot faster than it was before. And more importantly, it's a lot smoother. So what we're looking for is these kind of like rectangular bits. We want our we want our motion to be more rectangular than like curved. So if I do that thing again where I set my jerk really low and then I go to like, you see how it's like a triangle? Or like here, this is a better view. You see how it's like more of a trapezoid than a rectangle? We want it to be as rectangular as possible. Um, so just keep tuning it until you get something that looks more like a trapezoid, more like a rectangle, sorry, and less like a trapezoid, so that our motion is as smooth and as quick as possible. I noticed that I never showed a video of the ending of what it's supposed to look like, so I wanted to include one here. As you can see with the motion, it's a lot smoother than with just the PID on there. And that's important because as you can see, this one I was still kind of testing stuff out. I didn't have that realization that I mentioned earlier in the video, but you can see how before everything was slamming and there was a lot of harshness in the movement. But with these motion profiles, you can see that it's a lot smoother. And what we're doing here is we're sacrificing our speed just slightly. It's like a quarter of a second, just so that we ensure the safety of the motor and we ensure the safety of our subsystems. Um, this way, it's a lot easier to repeat motions because in FRC and robotics as a whole, we want repeatability to be our number one factor. And if we have issues where we are slamming into stuff, and especially on this robot, there was some issues with how there could be issues with the settings. There could be a random negative sign. And so with just PID, we might have issues where we see the robot slamming into the bottom of the elevator and that could break it or that could cause other damage. And so this is why we use motion profiling. So then that way we can minimize the risk while maximizing the motion and the efficiency of our motors. I hope you found this helpful, and I hope to catch you in the next one. See you.